So hi, thank you very much for coming to this talk. We'll be talking about containers, Docker containers specifically, and Kubernetes. My name is Brian Dorsey, and I live in Seattle, Washington. I'm going to step back, and I think that may reduce the reading. And so I live in Seattle, Washington in the United States. I work on the Google Cloud Platform team in developer relations. So I'm a software engineer who gets to talk to other developers, help you build things on Google Cloud, and if and when you run into trouble, take the feedback back and try to make the product better. So kind of this feedback loop cycle. So that's me. I'm online there. And next, okay, so back. A little bit of context. Google Cloud, we think about compute on a kind of a whole spectrum. So on the platform as a service side, we've had App Engine for 5 or 6 years. And how many people have done an App Engine app? Audience. Okay, so some. The idea of App Engine is that you write your code, and maybe with some constraints, and you push that code up to Google, and we run maybe a few copies, or maybe a lot of copies, and do all the load balancing and the database scaling so that that runs for whatever your workload size is. So if you have lots of users and scale up really fast, like an advertising site that goes huge for 3 days and then disappears, that works really well. But there's some constraints there to allow that scaling. On this side, we have Compute Engine, and that's just straight virtual machines. So these are machines running Linux or Windows, and you can run any software you want on them that runs on Linux or Windows. And but then it's up to you to manage these machines. Actually, you can even run BSD on them, but so you are in charge of running these virtual machines and all the security updates and everything. So you get a lot of flexibility, but you have to do more work. And if you think about cloud so far, many of the things that we're doing in cloud is taking what we do in the physical world and making software versions, right? So you take a computer, and you go to the data center, and you put a drive in it, and you plug it in, and you hook it to a network, and Compute Engine is all of those APIs as software. So you can write software to do all these things. But today we're going to talk about this middle part, where we can start to think about the whole data center as like one computing device. So we can package our software up in a container and push it out to a whole cluster of machines and say, just run this, and let it go. So that's today. I'm just going to use this phrase, distributed process manager. So as a shorthand for kind of where we're going with this is, like right now, on one computer, there's software like systemd or Upstart that does a really good job of, you'd say, run this program always. And it starts up, and when it crashes, it restarts, it helps with logging, it does a bunch of other stuff. And we need something like that for clusters of machines. So that's where we're kind of headed. So I'm going to talk a little bit about kind of building systems today for most of us, then Docker containers, then Kubernetes, and then a dangerous demo, and then a wrap up. So thank you very much. Okay, so have you seen the website highscalability.com? It's a blog that publishes regularly, and they do interviews with people who run very large websites, like LinkedIn or Facebook, and they get these people, Stack Overflow, right? And they find the full stack, the technology stack that these people are using, and document it. So it's really worth reading. And so this is kind of like a minimal version of that, right? Almost every site has a series of web servers. We've got a database because we need to store our data. Databases often become a bottleneck, so we need a cache so that you can read and not have to hit the database. And then there's almost always some processing that happens in the background. And then a real website will just have multiples of these, and it gets more complicated, and we have lots of batch. So we'll talk about this today. And I think most of us are deploying this so that there's one type of role, like one process, one kind of software per machine. So you've got like a web server, maybe you have multiple and they're hopefully all the same. Not that one that's bad. So you've got web servers and they're hopefully all the same. And then you've got a database server, and it's maybe beefy and don't run anything else in the database server because it's the database server. And then you've got cache, and you've got a bunch of back-end processing that's hopefully not running on your developers' machines. I've never done that, I promise. And there's a lot of reasons for this, right? It's risky to mix things together, right? You don't know what this software is going to do. You need to make sure nothing else affects the database. Even if you've got just straight software that you write in Python, Ruby, C++, whatever, there can be dependencies for those apps where this needs a particular version and that needs a different version, and you upgrade the one thing and the rest of the site goes down, things like that. So it's risky. From a management standpoint, you might be doing everything by hand. I hope not. There's a bunch of good tools today to automate deploying, setting up the environment for your machines. So you've got Chef, Puppet, Salt, Ansible, these guys, and they'll prepare the machine to run your software and the different kinds of software. And then we've got the actual computers. So maybe you've got physical machines that you own at your company or in a data center. Maybe you're running on a cloud somewhere. Maybe you've got a mix of these. And then you've also got your developer machines. You probably mostly have computers with you as well, laptops. And so we've got all this. And even if you get everything all automated and pushed out to your host machines, and they're all separate and running, that's a huge amount of work, right? How many people here have a test environment that looks like your production environment? Okay, you guys rock. That was a lot of work, and by the way, that's a higher percentage than I usually see. And if you didn't raise your hand, talk to those people, and that's awesome. And I think that's a big challenge for a lot of people. Certainly, some of the stuff I've worked on, we had a big distributed system running in maybe 20 different places around the globe, and then trying to deploy file transfer software to that was really challenging, because how do you test out all the different scenarios? And so we've got our app dependencies, different things there. Utilization, so if we are running all of the processes on all these separate machines, then most of the time the machines are pretty quiet, right? You've got enough hardware to go big when you need to, but you need to keep them relatively settled. And so you're not making the best use of your hardware, right? Like in a perfect world, you'd have all of your machines running really heavy duty all the time and no extra machines. And that's the most efficient dollar-wise and power and everything else. And then when you need to scale, you got to turn the dial and go bigger. That's really hard. And then version upgrades. Okay, so how many people here can deploy a new version of their app? You just press a button somewhere and it goes out. Okay, now how many can roll back? That's harder, right? So getting it out to going forward and then being able to go back is harder. So I propose to solve all of these by the end of the talk. So test me on that, we'll see. Or at least make really, show you a path to a really good process for seeing how this might work in a fully containered world. So then Docker containers. Just out of curiosity, how many people have heard of Docker? Woo, okay, almost everybody. How many people have actually started a Docker container yourself? Okay, lower. And how many people are running Docker in some kind of test or prod, but people are relying on it working? Fewer, okay, awesome. So that's actually a pretty good expansion out. The cool thing is there's lots of people in this room already with experience, so you can kind of start trading stories and experience. But I do think the patterns for doing this, we're still working it out as an industry right now. But it's a good time to be investing in it. And the thing to take away, so I'm going to talk about Docker and Kubernetes and such. But if you Dockerize your workloads, the way the industry is headed is all the big cloud players are all trying to make it awesome to run Docker on their infrastructure. The people who are going to sell you servers are all trying to make Docker run well there. So if you spend the effort to make your software run well in Docker, it's going to be worth the effort. So that's good. And this bit, so Docker itself is just a way of, I'm going to a few high-level things. It's really just a way of running a process so that it thinks it's the only process on the computer. It's a lie, right? But it's got its own file system. It's the only process. Maybe you've got a couple others in the same container, but they're all yours. And so it uses Linux kernel techniques. So you've got control groups and the namespacing stuff that let it behave as if it's the only one on the computer, But you can actually set limits on this. So you can say you're only allowed this much memory, this much disk, this much network bandwidth. This container is more important than this one, so if it needs to go, let it run instead of this one. Things like that. And if you're familiar with Solaris zones or jails, there's a long history of containerization of things. And this is kind of the next wave in the Linux world of this stuff, right? So you can think about it that way. Another way that I think is really useful to talking to other people in a large organization is to just, like, every time somebody says Docker or containers, say, yep, we're using this to build microservices, right? We've got like focused pieces of software and we're going to compose them to make services out of them. So we're building microservices. And my favorite way of thinking about these is that they're just processes. You know, these are programs that are running on our computers, but they magically have their own environment that's safe and clean all the time. So thinking about it as a process, you get this, two kind of big things. You get process isolation. So your processes shouldn't affect each other very much on the same machine, hardly at all. And you get to, and so this helps us, by the way, with this running only one thing on a computer, right? If we have good isolation, then we can start to mix things safely, and it's more fun, and better utilization of your hardware. And another way I like to think about this is they're kind of like static binaries. You remember static binaries where like you do a build and you take the executable and you give it to someone and it works? You're like, done? That's awesome. I want that back. But maybe some of you don't have like the fondest memories of static binaries, right? There's some complications that come with that when it comes to updating them and distributing them, and what do you do if there's a security hole in the library that you've then compiled into your thing? And another way of thinking about Docker and containers is that they're kind of a new like best of both worlds for static binaries, because these images that the containers are based off of, you make a static snapshot of the file system. And so each process sees the exact same file system state that you built every time it starts. And so you bring this around with it. So you deploy it, and it's got its own environment. It's isolated process, and it's got its own file system. So it thinks it's on its own computer. And then you need to make a change to that container. You can layer a new bit on top of that file system, say, oh, these things are changed. And then you just kind of push that delta update, and you restart the processes, and then they see the new world. So you can use that for updating your own software, updating your dependencies, all that stuff. So it's kind of best of both worlds of static binaries. And as someone kind of coming from a Python background, like that's really exciting. You know, in the Python world, we're kind of reinventing deployment every 3 or 4 years, because it's hard. And I think that this probably ends with Docker, right? Like you end up having a build environment that makes, you know, your program and all of its dependencies, and you push that around with containers. So containers everywhere, right? This is amazing. Let's put everything in a container. Let's run containers everywhere. It might be a little early for everything in a container. There's some debate about whether your databases belong in containers right now. But let's run containers everywhere. And if we're going to do that, we're quickly going to end up with thousands of containers. You know, we build these microservices, and each one is made up of, you know, dozens of instances, all running on all these different machines. And so we need, back to this phrase, a distributed process manager. We need to be able to see this thing as one world, right? And this is exactly the vision of Kubernetes. So Kubernetes is an open source project, started and released by Google, but already with many, many, many participants, both individual developers and large organizations. And it is a cluster management system, so that it's a scheduler for your containers, for Docker containers, across a whole fleet of machines. And these can be machines running in a cloud. Runs really well on Google Cloud, as you might imagine. Or they can be machines that you own. You can run a whole Kubernetes cluster on your laptop. You can install it on hardware in your data center, and it works. And you can run it on other clouds as well. We have adapters, and the whole thing is very pluggable. So it's up on GitHub. It's very, very active. It's also a fun way to see, like, you know, development live. You know, there's a bunch of code reviews up there, and people arguing about this, that, and the other. It's a great time if you're interested in this to kind of pay attention here. And there's very much, we're in the defining stages of lots of this. So it's very early. And if you look at this and try to use it, you're like, it doesn't have X, I can't do my thing. So file an issue to say it doesn't have X. This is a really good time for that sort of feedback, and we're really looking for it. So it's very active. Like you can see, like this is from about a week ago, 449 stars. We have something like 116 contributors, probably more now. Lots of stars. And this is a open source project started by Google. We already have committers from Red Hat and other organizations, commitments from CoreOS, HP, IBM. Mesos is implementing Mesosphere is implementing the Kubernetes API on Mesos. Microsoft is doing work with this. Like this is a crazy list of people, right? We got VMware and Microsoft and HP and startups all like working together with us building this thing. So we're really excited about it. And it's under very, very active development. It's very early. This is not the time to go immediately deploy stuff to production. It is the time to play with it though, and see how things work. And if it's not for you, you'll have everything in Docker and you'll be ready to try other stuff. But I think you'll really like it. And one thing I want to just kind of call out, it's kind of early in a project when like a recent release point is binary releases. So that's a joke. Thank you. So I'm going to talk about a few core concepts in Kubernetes. And the reason for this is kind of to set the context for what it is. But also, you might have seen other things. Google is running a lot of containers. Almost everything in Google runs in a container. These aren't Docker containers. They're mostly static binaries built, but they're using C groups and namespaces and all this stuff. And with Docker containers, like everybody gets this same advantage, even if you don't have one source tree for all of your code, right? You're pulling code from lots of different places. You set up the environment. Docker gets this nice abstraction. But we do think when you push it out to running on hundreds or thousands of host machines, you need some new concepts to keep it understandable so that you can like really reason about your system, about the network, and how it's made, instead of just having 10,000 containers running on your 1,000 machines and I don't know what's happening. So the first concept is a pod. And a pod is often just one container, but it can be multiple containers, multiple Docker containers. And this is, they kind of live and die together. So if you've got processes that need to be on the same host or need to interact with each other very, very tightly, either for latency reasons or read the same files, this is a way to kind of group them together. So most of your pods are maybe one container, but if you need things to be able to work really tightly together, this is the unit of scheduling in Kubernetes. So you've got this nice little abstraction, and it's template-based. So we'll show it in a minute, but you write a JSON document and say, we want this to be based off this Docker image, and it needs these resources, and schedule it somewhere that has those resources available. So you've got a template, you've got this guy. The next step is making sense of all of these. We've got labels. And labels are just key value pairs. So you've got a key and a value, you've got the name of this thing. And it's baked into most of the APIs. So you can, when you create the pods, you say, oh, this is named such and such, its role is front end, its environment is production. And then if you label your pods this way, you can ask Kubernetes questions like, how many front ends do I have running in production? Please shut down all of the front ends running in test and restart them, things like that. So you can talk to the API in groups. And this is key, because you don't want to be thinking about all of this stuff on a per machine basis. You want to just say, give me the things doing this work and make them do this, wherever they're scheduled. And this is like one of the core pieces for building these abstractions. And the next key core piece that we have here is something we call a replication controller. And this is a definition. You say, I want to run this pod 5 times, for example. Or I want to run this set of pods, right? And the replications controller's job is to turn it from a kind of an interactive, like, oh, do this, Kubernetes do that, this sort of thing, to a declarative state. Where you say, Kubernetes, always run 5 copies of this pod. If one of them fails, start a new one. So Kubernetes' job is to keep 5 running at all times. And when you want more or less, you update the definition and it adapts. So basically, this is the thing that lets us put the pagers down and trust that the systems are going to keep going. And this is kind of at the core difference. So as you're looking at different ways to run Docker containers, is the system maintaining state for you, right? So we've got a reconciliation that's going on here. So always Kubernetes is like, are these containers healthy? If not, I'll replace them with a new one, that sort of thing. And now it's demo time. Oh, I forgot to shut down the notifications. No one messaged me. OK, so I've got a directory here with this JSON file. So if we look at update controller, so this is a replication controller definition. You can see that it's set up to run 2 copies of this container. The container it's going to run is up on Docker Hub. You can run it yourself. It's amazing. It's a web server that serves up a single image. I know you're going to want to copy this. It serves up, and it's tagged with Nautilus. So this is the version that serves a picture of a Nautilus, and we'll get to see what that is in a second. And it maps ports out and does some things like that. And then we can run this command, and this is all in alpha right now. So I'm going to show you the Google Cloud versions of these commands. But underneath the covers, there's a Kubernetes command line to talk to the API that works wherever you have Kubernetes running. And there's a command line app that uses that API. So it's a REST JSON kind of API. So we basically say, create a new replication controller based on this document. And let's try it. Oh, and then down here, I have a web app that's sitting and refreshing against the API to show us which containers are running. So in a perfect world, we will start these containers. That pushes the definition out. It says, oh, we need 2 containers running. And hey, they started running, and now they're up. That was fast. So containers start really fast. And so even with a whole management system, like we're talking to an API, it's scheduling them, deciding which host to run them on. Like these start very, very, very quickly. So they're processes, right? It's great. So if we then say, oh, that's nice, but actually, I want to have 5 of these guys running, right? So I just changed replicas to 5. And then I can basically remove this definition and re-add it. Update's coming within a week, but basically you update the definition. And when we do that, Kubernetes will say, oh, the desired state is 5. I only have 2 running. Let's start 3 more. And then they come up and they run. And I just think this is really exciting. I just kind of like start and stop pods all the time. Have a lot of fun. We can, we even have time. Time allowed, we can take a look. These are real, if we refresh, this is the Google Cloud Console. Let me bring this up a little bigger. And this is the list of instances that are running. I've got 5 nodes running here. And if we come back here and I actually remember what this command was. Type it. So I'm off the demo script here. We're running wild. So our Nautilus demo is actually running on update demo node 3 on, so let's just grab that. And so gcloud compute SSH, it has this command to just SSH into a node running Compute Engine. And it handles the SSH keys and all that sort of stuff for us. This one is running in Europe West C, in theory. Oh, right, extra dot. And then, OK, connection refused. Not the demo I was supposed to do. So even if you delete one of these pods, which I will delete a different way. So this is a different UI that's made by one of our developer relations people in London. And this is hitting the same API, the Kubernetes API, and it's running with Polymer. So it's kind of polling in the background and then updating these web components to display things. And one of the things it has here is a little X. So I can just kill a node. And that's what I was going to do, go Docker PS and show you the nodes. And then we come back over here, and it should be right back. Oh, this is going to be so exciting. And so Kubernetes keeps all of your pods running, even if one gets deleted. There it goes. And like this usually comes back very, very fast. So I harassed it. Let's delete 3 of them. The demo doesn't work, so let's try harder, right? So I delete 4 of the pods, and then Kubernetes says, oh, hey, you asked for 5 of them running. Let's make these all go. And that's the core job there, right? So now we've got 5 of these running, and what I showed here is basically kind of a fairly simple part of an architecture, right? This is just a set of identical pieces all running. So this would be like something like the web servers. And Kubernetes figures out which hosts to put these on, schedules them. It's a fairly minimal scheduler right now, but that area is all pluggable, so you can write your own scheduler. We're improving the scheduler. There's work ongoing to get metrics back from the containers and then feed that to the scheduler. But anyway, they run on some of the pods, and then pretty soon you set up your whole architecture and you've got a whole bunch of containers. And even for that very simple diagram I showed, there's all kinds of stuff, right? So we need a way to find these guys and for them to find each other, because the front end needs to be able to talk to the database and the cache, and the backend processes need to be able to talk to the database. And the key abstraction here in Kubernetes is called a service. And I know that word's used for a lot of things, but in Kubernetes, a service is an automatically configured load balancer. So this is a load balancer that runs inside of your cluster, or it's actually multiple logical load balancers, and it's aware of the health of your pods. And so when you connect to the load balancer, then it sends the traffic to a healthy pod to handle, and if one of the pods goes down, like it'll get dropped out of the load balancing. So this is kind of the key abstraction for making sense of a more complicated system, a microservices. So you automatically in Kubernetes get real load balancing for all of the components of your system, which is pretty cool. And so it might look something like this. You've got a service in front of each of your replication controllers, and they find each other through that service. So, and the services are advertised through environment variables. So, you basically say, hey, give me the IP and port for my cache, might be Redis, might be Memcache, and then I'll connect to that, and it works. So that's it's a distributed process manager. And I can even, if I really test the demo gods here, we've got another example here that's called Guestbook, and it has pretty similar to this architecture. It's using Redis as a database, which is a little weird, but it's front end and database and master slave reading and writing. So I can actually go ahead and push this same thing, which is just a bunch of these push commands, and I can push it to my same cluster and run 2 completely different applications in the same cluster, because it's just one pool of resources. We could run test and prod on the same machines, whatever we want to do, and they'll happily do the right thing. So that's super fun. And the web UI that I showed here is just a sample app, kind of Node.js combined with Polymer, and it's up on GitHub called ContainerCam. So I'll have a link to that later. It looks like that. And so I just want to say, I think this is a really exciting time for being a developer, right? We keep moving up in abstractions. We get to focus on the things that we care most about, the things that our customers and our users care about, and can really start building systems at a higher level. And I think this is a super exciting time. It's also a bit messy. There's a lot of stuff going on. And you might have a question. This is the lead-in. Do I have to manage it myself? No. So Google has recently released a hosted version of Kubernetes as part of the cloud platform. So if you don't want to go and build the thing yourself and set it up on your own machines, you want to just try it out, see if it's worth your time, you can go to the web console, spin up a Kubernetes cluster today. This cluster is just a straight open source Kubernetes implementation running on Compute Engine, managed. We keep the machines up to date. We handle all the kind of grunt work, but it's the same exact thing. So when you set up the cluster, the Google APIs are for managing the nodes in the cluster. After that, you're talking to the same exact Kubernetes API. So you can have a Kubernetes cluster on site, and you can hit the same API with both of these. That's a little screenshot of that. It is alpha. at Google, we sometimes put beta on things for a while and like leave it that way. And oh yeah, you can. This is very early, so you may run into some ugly kind of complicated starting places. So if you do, please contact me or these links that I'll put at the end, where we're on IRC, we have mailing lists, and of course GitHub issues and that sort of thing. We're very, very much looking to make this process easy and do all the things you need to do. So if you like poking around at new features at Google, this is a link to a form to sign up with our web UX folks, the user experience for command line and web. And I'll have this on the next couple of slides as well. And basically, if you want to try stuff out and give your feedback on things, or if you have opinions about how how things should be, we want to hear it. So that's where that is. Also, everybody here today, if you haven't already gotten one before, gets $500 credit on Google Cloud. And this is also on this next slide, so I didn't mess you up. You can still take a photo. Promo code is try Kubernetes. Go to the link, starter pack. And this is $500 of credit to play with a cluster. It actually works for all of Google Cloud, but yeah, please give Kubernetes a try there. Website, GitHub repo, the container engine is the hosted thing, UX studies, and that is my talk. Thank you all very much. And actually, after this, I'm going to hang out in that cafe during the next talk, and I'm really happy to chat with anybody in more detail and other questions. Yes, sir. So the question is, if you're running on bare metal, you're running on your own machines, and you want to run some of the containers on certain machines, right? Maybe you've got a hardware reason for that. They need GPU, or maybe they need a certain network, or whatever reason. They need to run on certain hardware. It's a little kind of do-it-yourself right now. There's a little assembly. But essentially, you can set key value pairs on the hosts as well. And then you can set constraints for the pod, saying that it requires this resource. And then they'll only get scheduled on that. Some of that work is in progress actively right now. So it might make sense to join the IRC channel and see how it works. But I'll take that as feedback. We need a getting started for that. Yep. Yes, sir.
I was wondering what's the role of etcd in
Oh, yeah. So what's the role of etcd in Kubernetes? Etcd is a key value store that focuses instead of kind of like being able to withstand partition, but always being consistent. So etcd gives you a consistent view of the world always. And it's slower, like it takes longer to do a transaction because of that, but any process can talk to etcd and be sure to get the same answer back. So we use etcd in multiple places. We use it on the master node and on all of the main nodes. And we use it basically everywhere we need to keep track of state of the Kubernetes cluster. So that's how the master tracks where things should be scheduled. It's how the nodes actually know that they've been scheduled and to start things. It's where the declaration you make a declaration and that gets pushed down through etcd to all the places where it needs to actually happen. So if, for example, the master goes away for a while, the defined state of your cluster is still in place. And if you lose a pod, it'll get like replaced on that same machine. So all the same stuff will happen there. You just can't make changes to your cluster until the master comes back. And then the master is based on etcd. So if you've got etcd running, you can just kind of pop a new one up and it picks up where it's going. That's the high level view. There's probably other places as well. So yeah, so etcd is from CoreOS. CoreOS has also implemented a network abstraction layer that allows you to do software-defined networking things that Kubernetes needs on bare metal and on your own networks. Okay, 3, 2, 1, and we're finished. Thank you all very much.